Alright, well, I'm going to demonstrate how to hook up and disconnect a rail car. We're going to do everything up to opening up the valves and actually letting product flow through. Don't want to cover that at this point. Don't need to get over the fundamental basics of how to do it. Like I showed earlier, use a rubber hose is what we use for our nitrogen. Easiest way to do it is just kind of separate it out where you have your three small hoses there. We just this. I turned on my nitrogen down there at the compressor, so I pulled this out. You can watch that actuator open up. All part of the visual cues. We all look for visual cues to make sure everything is working as it should. So again, use all of your senses as you're doing your job. It's easy to get in a hurry and think you saw and think you heard what you're supposed to see and hear. As a rule, these will stay shut. I'll close my main vapor valves here when not being used. Since I'm going to get this ready, open that up. Get that ready. Finish uncoiling. Loop it around. We want to keep things out of our way. Stab it. That pulls the first collar down. Pull that back. Now you just sent nitrogen through the line. I left this gangway down earlier when I was taking readings. And you can just stay right there for now, but you see where the hinge is. When I raise this up, it's going to block my easy access over here. So we're going to put my initial fittings over here, and we're going to lay my hose over this rail. Want to go over a couple other things here real quick while I got it. Here's my Marshall ESV. That's my connector. And then I've got my fusible link right there. Melts at 212 degrees. That's a vent. If you have a nitrogen leak, this thing, if something internally goes wrong, this thing will vent nitrogen. And that's a good way to know if you suspect you have a nitrogen leak while you're hooked up. You can check this, but also check your vent. This is just a standard 2-inch by 12-inch Schedule 80 pipe nipple. You want to always keep an eye on this, make sure on your threads. We just basically want to look for damage. When you go to pull a plug out, if there's damage on a plug, you got to be careful. There's probably going to be damage inside that flange, could hurt this. Whenever you think there's excessive wear on your threads, put a new nipple in. At a minimum, this gets changed once a year. Every June, I'll go and check it. My hoses go over the rail. My stinger points this way. You make the transition here with this, just 245, 2-inch 45s and a close nipple. And then I always run steel. Steel nut, steel nipple. I keep this on here, just keep these on finger tight, so when they're propped up in here, it's very difficult for rain or snow to get down inside here. And the open parts just facing down there toward the bottom. These I put on fairly tight because I use this as leverage to go and spin these in. So when we carry things over, you always want one hand free to be able to give yourself some balance, something to hold on to as you're walking across. So you either carry your parts over one at a time, or you put them both into one hand, whatever you feel comfortable doing. So we're going to set this down. Going to grab a hose. I want to discuss a couple things here on these hoses. You have to designate which hose and specify which hose is vapor, which is liquid, the way I'm set up. I put yellow tape down around here, and this yellow tape is what designates this to be vapor. I put these plugs in here. The plugs are designed to be kind of loose like that is to keep the worst of the weather out. When it comes to grabbing these and moving these, the ideal that we shoot for whenever we're moving these hoses is to touch this as little as possible. I'm not going to lie to you and tell you that you're never going to touch it. There comes times where that's the only place you can really grab, but as a rule, you sit around and you think of ways, you know, you think it out in order to not have to grab it. And usually the easiest way to get it off is just grab it here. And you notice how I got that loop. The whole idea when moving hoses is not to fight this hose. This hose has its own natural bend, its own way it wants to move. Try to figure that out and work with it, especially when it's cold weather and this hose is very stiff. If you get into a wrestling match with a hose, it's a good way to damage your finger, your hand, hurt your shoulder, because this hose can fight you if it really wants to. And this is also where having these swivels here really pays off. It doesn't do a lot, but just click, you know, move it a little bit helps. So we'll just pick this up. I got a hog tail. I wrap this on all my hoses, and I primarily try to target it to where these are going to be wherever this hose is going to lay in contact with something. The liquids pretty much, once they pretty much lay flat until near the end. Your vapor always pulsates because of the compressors. So any place where a vapor hose can settle on, can rest on, you want to do something to protect that hose so it's not always vibrating against. Even a round, smooth metal like this, in time can wear through the outer layer of our hose. My hoses are smart hoses. That means that in the end here is a flap, and on the other end up there is a flap, and it's connected with a steel cable, to where if these smart hoses get stretched beyond a certain percentage of their length, or if they get broken, the cable will snap and it will automatically slam the little flaps closed on this end and on that end. And that way the worst you're going to lose is product that's in the hose. What I've bought, and you can tell by having this rubber ring here, is I bought smart hoses that have a swivel on the end. You can clock, it's a little tough to tell, but you see that? You can clock this, and that goes a long way toward helping you line up, because these railings are pretty far apart on this car. There's some of them where the railings are really close and these are really tough. Being able to clock these a little bit helps. So we're going to transfer this around. And for now, just going to leave it lay. Now we can just walk around. We got all of our stuff there. Now to hook everything up, we need our crescent wrench, pipe wrench. Same principle. You want to carry stuff in one hand, have the other hand free. So if that means 2 trips, it's 2 trips. If you can do it in 1 trip, it's 1 trip. Take that. I'm good to go. Put this down here near my sample line. Put that. I have established a routine here, and you are to follow that routine. You are not to deviate from the routine, because whether you understand it or not, if you do it the way I show you, it is the most efficient way to do it. And you just kind of reverse the process when we go to disconnect. There's a reason. We've tried all kinds of ways over the years. This has proven to be the most efficient and the one that puts us in the best position when we're done to not forget, or make it harder to forget. So These are Rego brand. And Rego are the best brand out there as far as I'm concerned. The other popular brand is Midland. Regos generally have the larger plug, so we want to open that rascal all the way up, get it on there. This is where it's very important. You always have to look where you're going to put your feet. You don't want to do it like this, where you're pulling across yourself. That puts a lot of your upper body, and some parts down here you put them at risk. Plus, look at your feet. Your feet are at a right angle to this. We want to do it in such a way that we're pulling it toward ourselves. You see where that handle touches this? It's going to touch pretty much the same way here. So watch where you put your fingers, and you keep your hands when you're pulling this over. Because if this slips, or if that plug gets really loose, you hit that edge, even though it's not very sharp, it will cut or break your fingers. So don't want to do it. And because we don't know how tight this is, you don't automatically just go and give it all you got. You figure it out. You apply some pressure, and that may be a little too loose, so we click it, get it a little bit tighter. 2 hands, keep them up near the top, and you change your center of gravity, because you just have to use everything to your best leverage. It's not just dumb strength, it's smart application of force. Remember that. A smart application of force. Because somebody bigger than you might have been the guy that put these in. And so we're not here to compete physically against everybody, but we've got to be smart about it. And this may be too much of a bite. Maybe better to turn it and go with a shorter bite. That's one nice thing about adjustable wrench. Or you could do that. The problem with that is you don't have much throw and you don't have much leverage. So, how about we do that? And that's a little sloppy, so let's click this up. That's about it. It's about the best we're going to do. So we're going to get some leverage. Yeah! That wasn't too bad. Compared to some of them, that's really not too bad. See, it's just hitting. You keep your hands away from it. And we can undo it by hand. They use Teflon tape to seal this. One of the problems, see if you can get the camera down in there and kind of see it, is Teflon tape fragments. If you can see that or not. And you can see all of them that are here. They're just laying around. So what we want to do is we just want to get the worst of them out. And that's it. Do yourself a favor. Try to get them out. So we're going to start at one end. We're going to work around. See how these are chewed up? Just chewed up. It's terrible. Because all these people have been doing is using pipe wrenches only. Well, good for them, bad for us. Holy smokes! That's bad. That one's getting bad. Because I got it to move, it took some force. That took more force than that one, but I got it to move. If the first time you go and you apply force, and after the first 1 or 2 seconds it will not move, go get a cheater bar. Go put that cheater pipe right on here. It's not worth the risk to your body. It's not worth it, especially when the footing is questionable up here. Same thing. We're just going to flip out Teflon tape, get the worst of it out. I have a strainer screen down in my liquid pipe before it goes into my tanks. Even with a strainer screen, you're still going to get shards of Teflon tape in your pump screens and in your vapor eliminator strainer basket. But let's do ourselves a favor, our future selves a favor, and put that down. Same thing, watch your footing. Pay attention, keep your center of gravity. If you feel like you have to do something like this to get it loose, no, stop, don't do that. Get a cheater pipe. I have that one in there. In the trailer, I got one that's 5 feet long. It's only been a few times I've had to use the 5-footer, but it's better to use that than put yourself at risk up here, because you slip. Hopefully you'll just hit this, and that's all that happens. We just don't want any trouble. So not so bad. That one's so bad. See how they got that all slopped up? They were using pipe dope along with Teflon tape. Same thing, always just wipe it out real quick. Now when it comes to putting in the stingers, you can stand up and lean over, or you can just get down right here. Some of these cars, you can see this has got a decent riser here. Some cars, that riser, the top of the car is here. It's not much of a riser at all, and it can wear on your lower back if you do it. Sometimes this is a pretty easy way to do it. We use oil to seal these threads. We don't use Teflon tape unless we see that this plug has damage, or when we first open it up, if this thing starts spraying a lot of liquid, then we'll shut down and then we'll Teflon tape this up. But as a rule, you don't need to. We'll come in, get it lined up, and start applying oil. And this is why I keep this cap on, because it gives me leverage to spin this on. There we are. We're doing good. That's all the oil that we need to make a seal. So now we draw it up hand tight. We keep an eye on where this connector is pointing. If this car, we're up high enough to where no matter which direction this is pointing, we can hook up. Some of the cars where they're really close, you got to make sure that this isn't pointing down when you get done. So we take this. Like I said, this is not a strength competition. It is a proper application of force. So that's getting tight right there. I can crank that tighter. But there comes a point in why. As long as this makes a good seal, that's all we're after. I'm going to call that a good seal. Now we're going to disconnect this. Because it's kind of raining out, lay it down. Take this, spin it on. Good enough for now. Take this off, lay it down. Bring this around. Same thing, we're going to put it down so it's not going to pool in water. Slide your nut back, get your nipple to drop, and that's, you kind of tell if your nipple is square enough to get this nut to spin. Because if you spin this several times and it doesn't engage, it's just because your nipple isn't lined up, that's all. It's decent weather out. Everything is pliable. Just cranking it down by hand, 95% of the time will do it. Usually you need this in colder weather when your O-ring or your flat washer is a little colder and it's shrunk a little bit and it's harder. This helps out. Then what you do to get this one tight, just lift back a little bit, spin that nut. That's it, we're done. Now that we've got this in, and remember, we're kind of blocked off here. And once we put in this stinger, that kind of makes getting over here a little more difficult. So now is the time to bring our nitrogen hose over, hook up our nitrogen hose, open that valve so that we don't have to step over here again in order to offload this car. So be right back with that. as you take your hose, you want to make sure it lays as flat as possible, and in such a way that it does not become a trip hazard. So, lay this out, get one of them. We confirmed our actuator is open, so we know we have nitrogen coming up to there. When you hook into these and the nitrogen is engaged, it'll pull the plunger back. You'll know it because you'll hear it. So listen. Hear that thunk? You have to listen to that. It's easy to get in a hurry and not take that half a second to listen, because now we know that that opened. So if for some reason initially we don't have flow through this hose that we can see through our sight glass, we at least know that that opened up. So it's just part of what we pay attention to. And now this hose, this liquid hose, has really nothing but pressure in it because my back check valve isn't letting any other liquid. My back check valve only allows liquid flow to go out of the car into the system, not from the system into the car. So now's the time to open this up because we want to get pressure in here going to that valve. So now we got that open. This is pressured up enough to where it's going to be safe. So now we're going to get our stinger and we're going to get our big elbow, because this vapor hose is going to come across here. So we have a small elbow there to make our turn. We now are going to have a double elbow to get us from pointing that way to pointing back this way. One thing to give you a tell to watch is how many threads are left. That flange is pretty well worn out. I should have more thread than that, so I'm not anticipating being able to thread this in too much farther. So one hand, I don't need both hands cranking this in. There, we're getting tight. That's it. If it leaks badly at this tight, the answer is not to keep cranking it. The answer is take it apart and Teflon tape that up. I don't automatically Teflon tape any of these because, like I showed you, you get Teflon tape shards. It's inevitable. They strands, those little things, and they always get into your system and they always cause some sort of trouble. Let's eliminate it. Let's don't even let it happen. This oil makes a good seal. It's not a permanent seal. It's not. This isn't a permanent piping system. This is a seal to get us to accomplish our job easily, and it creates very little mess. It creates no long-term problems for the next guy, nor for us. Get off of there. Now we got that. We'll take our cap off. You see I've got the sample line valve. When we use this valve to prove that the car itself is empty, because as we're emptying out, our glasses will go from clear to turbulent, and then they'll start getting more and more and more and more clear. Well, you have to prove that the car is empty. So you pull your plug, you open this up, and you let it just shoot out nothing but vapor for 10 full seconds. That's your best way to prove that the car is empty. If you use your piping, by some guys, a lot of guys, put a valve in their piping and they'll open that up, and then when their piping blows clear, vapor only, that's their indicator that the car is empty. Unfortunately, one of the problems with that is that sometimes these pickup tubes down inside here can rot. Okay, can get holes in them. They can just go bad to where the car, you actually are running no liquid, all vapor, 100% vapor, yet there still can be vapor inside the car. That's happened to me twice. And at the time, I was using the alternate means of testing my piping to make sure it was empty. I wasn't using this exclusively, and that cost me. That cost me, like I said, on 2 cars. So anymore, don't make that mistake. And so you'll open this up, because if this thing shoots out just vapor, and these are shooting out just vapor, that's as best a guarantee as you can possibly get that there's no liquid left in the car. So now we took this apart. This is the same thing, it's just 245s. I despise 90-degree elbows. I hate them. Sometimes they're a necessity though because of limit of room. So as long as I got the option, I never use 90s, I only use 45s. Once again, I only use steel. I don't like having any brass fittings. One interesting thing about Acme threads, when they wear out, they tend not to wear out on this face. They tend to wear out on the back side is where they tend to get thin. So steel ones can take a lot more abuse and keep you in the fight a little bit longer. So same thing, we'll come over our chain. You either come over the chain or come over this side of the chain, one way or the other. And then you got your nipple. If you get it to line up and drop, that's your good indicator your nut's going to spin right on. So we're pointing the right way, so we're going to use this as our leverage. And we're just going to put pressure on that nut. Now that nut's tight, so we're going to take this off. Lay it down. And because that liquid hose and our vapor came off on the same side, we're now going to bring our vapor over and hook it up to here. The vapor either has to go over the top or it's got to come through. I found that the easiest, safest thing to do in this situation is come over the top. And then here comes where you have to realize how to handle the hose the right way. It's not to fight it. It's not to be here and wrestle with it. Figure out how it wants to turn, how it wants to move, and use that to your advantage. I want to make sure it stays on the outside of that when I'm done. Now count on that swivel. There, just that little bit helped. Now, I estimate about how much hose I'm going to take from here to there. And that's what I take. Now I just pull it forward. I'm not pulling the whole hose, I'm just lifting this up. See how close I got? Just a good estimate. Now I'm not trying to fight that hose. I'm just trying to get that hose to do what I want. Same thing. Get it to line, get that nipple to line up, hold it. Makes it a lot easier to spin that nut on. And if you want to, now's a good time just to use the wrench. Nice and tight, nice and easy. Now's our time to do our second hose. Come here, listen for that thunk. Now we know it opened. Now we can open this. Because when I offloaded my last cars yesterday, I pulled them down to 2 psi. Didn't intend to go to 2 psi, but by the time my timer went out, it ended up being 2 psi. So this hose is roughly 2 psi. And so right now my risk of anything is really low. Because even if those were to leak badly, I can only leak out what's in my liquid hose. If this one were to leak badly, I'm leaking out like 2 or 3 PSI. I can handle that. That's why having these kind of gloves, even though they're really not a liquid propane resistant glove, it's a more than sufficient glove to do what I'm doing at the time. And so I got these open, this open, leave these closed until everything is hooked up and ready to go. And I want to get that out of my way so I don't cross it over. Now it's time to go grab my third one. Same thing as the other two. Look at that. I only got like 2 threads showing. Those, these threaded face plates, these threaded flanges are getting worn out. That's it. No more tighter. I don't need it any tighter. I just need it tight enough to do its job. And because I have to open this up to prove that when the car's empty, I really don't want a bunch of plastic pieces sitting in here that's going to reflect all that propane vapor I dump out. I don't want it reflecting and bouncing around, so I just keep that little pocket open, provided I can. This is a standard car size. Some of the older cars, this housing ring is only about this big. Meaning they cut it way off to where it's really, really tight. And when they're really, really tight, everything kind of gets stacked up upon itself. I prefer to never, once I bring my tools out, I never put them away until I'm done. It's just, I don't. Simply because I just don't want that extra walking back and forth. Because the more and more and more you keep walking back and forth, slowly, 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 you start upping your risk factor for a trip or something. So, set that there. My last liquid. And like I said, these swivel, so if I needed to, I can do something like that to give me just a little bit better position. And I can use that hose. Same thing, listen. If you hook up and they make no noise, immediately assume your nitrogen is not turned on. Go prove your palm valve is on, and you have that visual cue of your actuator up there on the vapor line. That lever has to move. And if it moves, then you start backtracking to find your other problem. Now this one here we're ready to open up. Now we're ready to open these up. And like every other valve, everywhere in the system, you don't just rip them open as quickly as you can. You do everything smoothly, because it's all about controlling flow. We want the product to move. We want it to move not only where we want, but we want it to move when we want it to move. And we want it to go without giving us any trouble. So since I'm not going to be actually offloading this car, I'm now going to show you the process of disconnecting a car.